19. This thing is getting pretty close to being over, which is slightly exciting. And I think it is ready. Day 19, go with the flow. So day 19, go with the flow.py. Okay, the most important part of doing it is naming the file right. The Elvis hole back on the way to constructing the North Pole base, you turn your attention back to understanding the inner workings of programming the device. You can't help but notice that device's opcodes don't contain any day 16 jump instruction. Programs where flow control is required, the instruction pointer can be bound to a register, so it can be manipulated directly this way. Set R, set I can function as absolute jumps, add R, add I can function as relative jumps, and other opcodes can cause too fast any effects. The mechanism is achieved through a declaration like IP1, which would modify register 1 so that accesses to it let the program indirectly access the instruction pointer itself. To compensate with this kind of binding, there are now 6 registers. The 5 not bound to the instruction pointer behave as normal. Otherwise, the same rules apply as the last time you worked with this device. The instruction pointer is bound to a register. Its value is written to that register just before each instruction is executed. And the value of that register is written back to the instruction pointer immediately after each instruction finishes execution. Afterward, move to the next instruction by adding 1 to the instruction pointer, even if the value in the instruction pointer was just updated by instruction. Because this instruction must fetch blah, 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 blah. Pointer to 0, 1 during the second, and so on. If the instruction pointer or cause device to start out, the program really halts. There's no frame time from useless CPU device number. You dump the background declarations, making sure to use the names of the opcodes rather than the numbers. For example, suppose you have the following program. Instruction pointer 0, set I501, set I602. When executed, the following instructions are executed. Each line contains 5 IP equals 0. Do this, set I501, IP equals 1, set IP equals 2, IP equals 4, IP equals 6. And then 0, 1, 2, 3, 4, 5, 6. When running this the first line, IP0 indicates the instruction as not instruction, blah, blah, blah. Instruction pointer contains 0, so the first instruction is executed. It updates register 0 as the current instruction pointer. Set register 1 to 5. Sets the instruction pointer to the value of register 0, which has no effect, as the instruction number of register 0. Adds 1 to the instruction pointer. So it's 1, blah, 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 blah. Instruction pointer is 6, so it stores 9, register 5, so causing okay. So, it sounds, hello one of you, sounds like I can mostly copy a lot of code from day 16. So let us go, and unfortunately I don't think I can import it because I think it's slightly different. Is that right? No, actually I think we might be okay. So let's see if we can get away with this. From day 16 chrono classification, import registers and instruction. Okay. And so now what I want to do is I want to say from typing import list, and we'll say a program is a list of instructions. And what I want to do is execute program, which is a program, and then also let's say registers, which is registers, and IP, which is an int, which is the instruction pointer, and it is going to return me it's going to return me registers as well. And I think I wrote this in an immutable way. Is that right? Yes, I wrote this in an immutable way, so that's good. So what do I want to do? So I want to say while, okay. Okay, so while, IP is going to be, so first we'll assert that IP is between 0 and len of registers. And so what I want to do is I'm going to say while registers IP is less than the length of the program. Okay. I want to say instruction equals program I. Let's go back and see what this says. When the instruction pointer is bound to register, its value is written to that register just before each instruction is executed, and the value of that register is written back to the instruction pointer. Okay, so instruction equals program I, and so get the corresponding instruction, write IP to the so instruction pointer is bound to a register. Afterwards, move to the next instruction. So the instruction pointer is instruction pointer should be bound to register 0. So let me call this IP bound, and instruction pointer contains so the registers always start at 0, so I don't think I need to even pass those in. So so I start with IP equals 0, and registers equals, so I don't need that either. 0, 0, 0, 0, 0, 0. So there's 6 registers. And so now what I want to do is I say while IP is between 0 and length of the program, instruction equals program IP, registers IP bound equals IP, and then what I want to do is registers equals instruction dot, why is my autocomplete not working? I don't think I hard-coded 4 in here anywhere, did I? No, I didn't. Instruction dot operate on registers, and then I want to write it back and say IP equals registers IP bound +1. Okay, and then I want to return registers. So, and I'm just going to print the registers while I'm testing this, and then I'll delete it. So we have this parsing code. So how did I get the instructions? I didn't, so I'm going to have to write a parsing code for that. Raw equals this. Def parse raw string goes to a list of instruction, and that's and I'll just call that a program, if you will. So program is an empty list, and then let's say for line in raw.strip.split on new lines, and let's say opcode ABC equals line.split, and then program.append instruction of opcode ABC, which I think is how instructions look. Opcode ABC, yep. And then I want to return a program. So program equals parse raw, and then print execute program. So IPython run day 9. Seriously? Did I really do that? All right. I called the file wrong. Day 19, go with the flow. Name instructions is not defined because it's a list of instruction. Execute missing one, IP bound, that is true. So we want IP bound equals 0, I think was what we said. Run that. One positional argument. Because I closed a parentheses there. And then I forgot parentheses there. List indices must be integers or slices, not string. So let's look at program, and because I need to do int A, int B, int C. Somehow in my mind I did that, and then I guess in real life I didn't do that. So this is saying, so let's see if this looks right. So 0, 0, 0, 0, and then it goes to 0, 5, 0, 0, and then it goes to 1, 5, 6, 0, 0, 0, goes to 3, 5, 6, 0, 0, 0, goes to 5, 5, 6, 0, 0, 0, goes to 6, 5, 6, 0, 0, 9. So it looks like I'm doing the right thing. Okay, so that's good. And so let me delete this, and 2, let me add an assert here. Assert execute program I equals, and it equals this thing. Okay. So now I have some kind of actual what value is left in register 0 when the background process halts. So let me do this and say this is day 19.text, and this should have been stuck in data. So let's do that, put it there, save it. And now we have this weird thing where where we have IP2. So let me do the following. With open data day19.text as f raw equals f.read, and let's just say lines equals raw.split on f.read.strip. I'll say line, and then and let's say IP bound equals lines 0 dot split -1, and we want to make an int out of it. So I'll take the first line and split it on that space, and then take what's after that and int it. So that should be 2. And now let's reassign raw as new line join lines 1 up to the end. And so I actually don't need these to be in the with block. And let's say program equals parse raw. And let me just run that and just make sure it looks right. Program. So the last one is set I 052. Set I 052, so that looks good. And the first one is add I 216.2, and that looks good too. And then IP bound is 2, so that also looks right. And so then what I want to do is go here, and I want to print execute program IP bound. And it's possible that they've done something wicked where this program's never going to finish, and I have to like take a step back and reason about it. They did that one year, and it made me very angry. So let us think about this. But 1488, that's a wicked number for an answer. But let's try it. That is the right answer. I got rank 164 on the stars leaderboard, and I'm 1 gold star closer to fixing the time stream. Continue to part 2. A new background process immediately spins up in its place. It appears identical, but on closer inspection, you notice that this time register 0 started with the value 1. What value is left in register 0 when this new background process halts? Okay, so now going to okay, so we'll say initial registers equals none, and so if initial registers is none, registers is that, otherwise registers equals initial registers. Okay, so print execute program IP bound 100000. So that's 6 registers. The first one is 1, and that seems to be, it appears identical. When I click this position, you notice that this time register 0 started with the value 1. So we can try this, and again, it's possible that it will run forever, which will be sad, but and you never know how long this thing's going to take. It could take ages. And so, once again, we will try breaking out of the system. So what we will do is we will print IP and the registers. So let's try this again. That's a huge number in okay, so these bastards, and I don't call them that lightly because they are bastards. They want me to reason through what this program does, and that makes them, you know, supremely wicked people. So what's happening here is that it's doing kind of 2, 3, 4. It's doing 9 times. Okay, so we're going to have to frickin' jerks. Okay, so instruction pointer is 2, so that's okay. So this is just like which instruction am I repeating? 2, 3, 4, 5, 7, 8, 9, 10. 2, 3, 4, 7, 8, 9, 10. And all right, so we are going to have to annotate this bad boy. So let me make a copy of it. And day 19 annotated .text. When they did this last time, I literally just gave up, but okay. So and this is going to be a big nuisance to me because these lines are actually off by 1. So so let's figure this out, and we'll figure it out by going to day 16 and refreshing ourselves as to what these things mean. add immediate. So add immediate stores into register C, register A and value B. So this is saying add 16 to register 2. Okay. Set I, set immediate 113. So set I stores value A into register C. So set register 3 equal to 1. God, I can't believe I'm doing this. I should quit. Set register 5 equal to 1. Multiply register. So mul r is so I'm just going to write r2. So in fact I'll do it like this: plus equals 16. This is r3 equals 1. Is that how set I? Stores value A into register C. Yep. R5 equals 1. R4 equals R3 times R5. Equrar, that's sets register equal to C. R4 equals 1 if R4 equals, if R1 equals R4, else 0. And I have to really do this 36 times. So add register to, so R2 plus equals R4, and then add immediate R2 plus equals 1, and this is R0 equals R3, because it really equals R3 plus 0, but add immediate, so this is R5 plus equals 1, and GTRR, God, I really don't want to do this. So now let me go back and say we are going to, our IP bound is 2, which means so I start with instruction 0, and it says add 16 to, so that should be add 16 to R2. So why is that not happening? So I start with instruction 0, and somehow it adds 5. I feel like I did something wrong here. So let me go back and look at this, because that actually does not look right. And because this should be IP equals registers IP bound. Okay, so that's one thing. So put so let us go back and look and see if it is actually doing the right thing now, although I still don't quite understand. how this can be the case. How is that 0, 0, 0, 0 when it should be, am I running something else? Maybe that's the problem. Okay, there we go. 1. So I have an instruction 0, and instruction 0 says I want to add 16 to R2, so that's right. And that's my, so jump to 17, 17 through 35, and that sets me up to, it puts all these terrible things here. Then I go 1 through 11, 3 through 11, 3 through 11, 3 through 11, 3 through 11, without 7. So 3, 4, 5, 6, 8, 9, 10, 11. So let's reason our way through those. So this is 3, 4, 5, 6, 8, 9, and this is saying R4 equals 1 if GTRR. So I need to GTRR. So if register A is greater than register B. So if R5 is bigger than R1, else 0. This is 10, and it's saying I want to R2 plus equals R4. And this is 11, which says R2 equals 3. So in particular, go back to instruction 3. So R2 plus equals 1. This one says skip 8, so that's fine. So now let's think about what happens. I want to multiply R3 and 5 into R4. So that's step 3. So step 3 says multiply this and this. So basically, multiply the last one by multiply. Why is that? So that's not right. R4 equals 0, 1, 2, 3, 4. R4 equals R3 times R5. But that doesn't seem to be happening because R4 equals R3 times, actually that does seem to be happening. Okay, so it does happen. Then set it to 1 if R1 equals R4. And notice that we're never touching R1, right? So, so at this point in time, so let's go here, and let's say R0 is none of these touch 0, right? So R0 is 0 and is not being touched. R1 is this huge number. And is also not being touched. And let's just find when we're here and just start with, let's say 2104. Rest is 2104. Okay. And now, so I'll put that one back, and I'll get these out of here too. When we get to step 3, and that's at the start of step 3, so R4 equals R3 times R5, so I'll stick a 4 there. R4 equals 1 if R4 equals, so if by multiplying these I get to this thing, then I set it to 1, okay? And if that ever happens, R4 is 1, which means R2 is this, which means I skip that, and add register 300, so this is R0 plus equals R3. So okay, so R2 plus equals R4, and then R2 plus equals 1. So we can sum up this, all of this. Okay, so we can sum up as actually even that, right? So if R3 times R5 equals R1, then I want to set R4 to 1. Set R4 equals 1, else set R4 equals 0. And then R2 goes up by R4. So if R4 is 0, then we basically go here and say skip this. So if those are equal, then we'll finally hit this thing and say R0 plus equals R3. Okay, and that handles all of these. So that's what these 4 things mean. So then we say add 1 to R5. So we keep doing that. And then R4 equals 1. So again, if R5 is bigger than R1, then set R4 to 1. We're going to skip over 11. And so let's change it the other way. So if R5 is less than or equal to R1, this thing gets set to 0, which means this thing gets set to 0. So, sorry, this thing gets set to 1, which means that we skip 11. Skip 11, else go back to 3. So basically, all we're doing is we're adding 1 to R5 until R3 times R5. So we want R3 times R5 equals R1. Now, R1 is this. R1 is this. We keep adding 1 to R5. We're not touching R3 either, right? So R3 is 1. So need R5 equal that giant mess 2. And now can't deal with trolls while live coding. Especially not on one of these evil reason outside of the system problems. You've already wrecked my train of thought. Okay. So if I go back and look at these, basically what happens is R5 just keeps going up, right? And it keeps going up and it keeps going up and it keeps going up, and this R3 is never changing. So it's just going to keep going up until it equals this nasty number in the second column. Okay, and so now we are here with, so this is 12, right? So it'll be 12, freaking messy number. Sorry, not 12. These are all zeros. 0, 12. 1. And so let's go back. If R3 times that 5, add sorry. Screwed this up. When did I add to R0? Add R. Oh. Got it. So actually, no. I set if R3 times R5 equals R1, R0 plus equals R3. R3 was 1, so we'll just go to 1 here. And then 12, 1. Oh god, this problem. If R1 equals R4. So now that thing is 1, so R4 is also 1, and R5 has to be this nasty number. And so I think that's how things look when we get to here, right? So we get to here, we said R4 equals R3 times R5, which is this times this, and now it's true that that equals that guy, so R4 gets set to 1. R2 gets R4 equals that. R2 is my register. He gets 1 added to him now, and so he skips over that. And now he goes here. R0 plus equals R3, so we add 1 to him. So that's right. R2 plus equals 1. So I feel like that R2 plus equals R4. So I skip that guy. This is actually skip to, oh man. Sorry, I totally lost my train of thought. That's what I get for trying to interact with you guys. So basically, I keep adding up, adding up, adding up. So let me, fuck. move this out of the way just so I can. So what I'm saying is I am going to end up with 0, that 3, and then 1, 0, and then this large number. Okay, and so I'll get here, and then R4 equals R3 times R5. So now this thing is here, and also I stick a 4 here because that's my next instruction. Then R4 equals 1 if R4 equals 1. So now we set that guy to 1. So we set him to 1, and instruction goes up by 5. Okay. And then what I say is R2 plus equals R4. So I add 1, and then I add another 1, which is 7. And then skip me. And then, so I'm here. R0 plus equals R3. So so I add 1 to him, and now I increment this guy to 8. And then he says R5 plus equals 1. So R5 is the last guy. So he goes here, I think. And again goes there. R4 equals 1 if R5 is bigger than R1, else 0. R5 is bigger than R1, which it is. So that doesn't do anything here. And except this gets incremented 10. I feel like I've screwed something up. So this is like, actually, you know what? Let's do something smarter than what I'm doing, because I'm doing something really stupid here, which is def one step program registers IP bound equals 2, and that's going to return registers. And so what I'm going to do is I'm going to say IP equals this. Instruction equals program IP. Registers equals that. And print God, I fucking hate these kind of problems. I hate them so much. So one step, and IP bound equals. So the instruction pointer contains, first line is bound register, there's no instruction. The instruction pointer contains 0. The first instruction is executed. Deputies register 0, the current instruction pointer value, puts the instruction pointer blah, blah, then adds 1 in the instruction pointer. instruction pointer contains 1. So the second instruction to execute is similar. The instruction pointer is left with the value 2. Updates register 0, sets register 0. Its value is written to that register just before each instruction is executed, and the value of that register is written back to the instruction pointer immediately after each instruction finishes execution. Okay. Afterwards, move to the next instruction by adding 1 to the instruction pointer, even if the value in the instruction pointer was just updated by an instruction. So let me do this. So the instruction pointer is the second register. Instruction is a program with that pointer. Registers there. Register. Value is written in that register just before each instruction is executed, and the value of that register is written back to the instruction pointer immediately after each. So so I need IP bound equals IP int IP bound equals 2. So what I need to do is I need to say registers equals registers this. So registers IP bound equals IP. Is that right? Instruction equals program IP. Registers equals instruction operate registers. IP equals registers IP bound plus 1. And return registers IP. So let me do this. And I have a program. And now let me go to my stupid annotated stuff and say that I am here. So I'll say reg0 equals this, and IP equals 3. And so one step reg0 IP. No. One step program reg0. I think that's right. And then one step, I'll do this, _1. And so this is saying that I was going to get 1 0 11 1 so 9 R4 equals 1 if R5 equals 1, that's 0. In 10 R2 plus equals R4, so that's going to skip 1, and then we get to instruction 12, which is that. So and so now So it is going to so this goes 1 1 1 1 1 0 back to 2. So this goes up to 2, and it is going to and so now the 0 1 2 3 is stuck at 2, right? So let me go to reg 0. Let me say reg 1 equals reg 0 equals reg 0 slice, and reg 1. So now we're saying this thing is set to 2. So that's 0 1 2 3 2. So now let's say one step reg 1 I same thing, I went to the wrong one. Okay. And then keep doing this. Stuck something terrible there. Okay, well that was not right anyway. So let me start over again. So one step program reg 0 IP, and now this, now this, now this, now this, now this, this, now this, now this, now this, back to 2, adds 1. So what was that condition that did this multiplication? R4 equals R3 times R5. So now R3 is going to be 2. So it's going to stop when that R1 equals R4. So what is so now I have 2. So basically, when I have 1 here, I want to find the thing that multiplies it. Then when I have 2 there, I want to find something that multiplies it by 2. And it's never going to find that. And so, but once it gets here, it's going to say, screw that. So R0 plus equals R3. So that is only if I find a divisor. And it is basically going to so this is going to square register 2. So here's what I think. I think it's going to loop, and if it's going to go 1, 2, 3, 4, each time that number divides this big number, it is going to add 1 to this and then go back. So I think it's like counting factors. And so the question is, when does it finally stop? And because, so I get here, I get to 12, and now basically from 15, so line 12, I add something to the factor. So this is 12, check the next factor, candidate, or sorry, increment the candidate, in register 3. So register 3 is the candidate that we want to check if it's divisible by, and then this is greater than register 3, 1, 4. So now I have to remember what GTRR is again. I hate this problem so much. Set register C to 1 if register A is greater than register B. So if R3 is bigger than R1, R4 equals 1, else R4 equals 0. And then this is saying add R4 to R2. So basically, skip this. So we'll skip this if R3 is bigger than R1. Otherwise, set immediate register 1. So set I, and what is set I? Sets value A into register C. Otherwise, go back to step 1. Okay, and then otherwise, square. So multiply register 2 times register. So square register 2, and this is, this is 12. This is 13. This is 14. This is 15, and this is 16. So set it to 256. So basically we're going to keep going until R3 is bigger than R1. So we're going to, in particular, we'll include it when they're equal, right? So if R3 is greater than R1, then we'll skip it. So basically, we want to know how many factors does this stupid number have. So def all factors and int, and how big is this number? 10 million. Okay, so for I in range 1, n plus 1, if n mod I equals 0, so factors equals this. Factors dot append I, and f equals all factors of this number. So this is not the fastest way to do this, and just because I love it, let's import tqdm for I in tqdm.trange this. So let us. Oh, that's fast. Okay, f, and as always, I forgot to return anything from the function, so I'm stupid, but okay, so here's f. Len f is 16, so that means there's 16 factors, which means that that thing should have gotten incremented 16 times, and I may have an off by 1, but let's try it, and that's not the right answer. If you're stuck, there are some general tips on the About page, or you can ask for hints on the subreddit. So thing is, I'm pretty sure about what I did. So there might be like an off by one or something. But basically, keep going up. There's not 256 registers, so this will quit. So we want to skip this if R3 is so GTRR. I'm impressed you guys are watching this because it's going to be boring as hell. And I did this because I wanted to go back to day 16 and look at those codes again. GTRR sets register C to 1 if register A is greater than B, otherwise 0. So if register 3 is bigger than register 1, and again, register 3 is this guy. So register 3 starts off with 1, and then each time I do it, I'm going to increment him another time, and am I not adding the right thing to, what am I adding to 0? Add register 3 to register 0. Okay, good. So I want to sum these up, not count them. So I have this F, sum F. So that means that I probably want the sum, not the count. So let us try that. And that is the right answer. And I got rank 103 on this STARS leaderboard, which means that if I hadn't screwed it up that first time, I would have been in the top 100. As I said, I hate this problem. Did I mention that I hate this problem? I hate this kind of problem. So part one was fine. Part 1 was just, run your registers, run your program. Part 2 was they gave you a program that would have taken years to run. And so you needed to go through and reason about, and they did this last time too. Like they gave you the registers and then it turns out the program was computing prime numbers or something, and you had to that one I actually gave up on and went and cheated and looked at the results because I didn't even think of going outside the system. Now I know you've always got to go outside the system because yeah. So so then you got to sit here and what the hell does this assembly code mean and what's it doing, and turn all these EQRRs into actual logical if-then statements and puzzle your way through this. And it's a real pain in the ass, as you can see. And it's satisfying in the sense they got it right, but it's not fun. It's like you took a class and this is your final exam and you got to puzzle over the right answer. So yeah. Anyway, I get it. I'm not a fan. Get add data, get add day 19, go with the flow, get commit day 19, get push. So yeah, so we got it to work. Like I said, I think if I hadn't screwed that sum count thing up, we would have actually gotten in the top 100, which is kind of cool. But this day 15 is notoriously absent, but I'm pretty cool with that, I think. And thank you to the 4 of you who were watching. Find me on Twitter at Grus, here on YouTube, which you're watching, so you probably know how to find it. And then I have this Patreon that I set up that you can kick into if you feel like it, and not if you don't. So that took us about an hour, and it was quite a painful hour. Hopefully it was less painful for you than it was for me. But enjoy your evening, enjoy your live coding, enjoy your advent of code, enjoy your holiday season, and I will see you probably tomorrow.